We are handing over more and more of our world to artificial intelligence. I mean, think about it, from the jobs we apply for to the loans we need. But as these systems get more and more powerful, a really big question starts to loom over everything.
And that's the big one, isn't it? Can we really trust it? This isn't some far-off science fiction scenario anymore. AI is making huge, high-stakes decisions every single day. And when it gets something wrong, the consequences, well, they can be really, really serious. So what happens when that black box makes a bad call?
Well, let's look at a few examples. Imagine an AI recruitment platform, right? It's designed to find the absolute perfect candidate. But here's the catch. It's been trained on old historical data. So it accidentally learns to favor certain groups over others, and it starts unfairly screening out amazing qualified applicants. Your dream job could literally be tossed in the digital trash by an algorithm before a human being ever even sees your name.
Or how about this one? A bank decides to train its customer service chatbot on real customer account info. Seems smart, right? Super efficient. But then the AI starts, well, leaking sensitive personal data in its conversations. This isn't just some theoretical risk, it's a massive privacy breach just waiting to happen. And then there's the security side of things, which is just evolving like crazy. Criminals are now using incredibly sophisticated deepfake technology to fool AI-powered ID verification systems. They can impersonate customers and just drain their accounts. The very tools that were built to protect us can be turned right back against us. Okay, so how do we stop all this? How do we build AI systems that we can actually rely on? Well, the answer lies in a professional discipline that's becoming one of the most important fields in technology: AI auditing. It's all about putting these complex systems under a microscope to make sure they're fair, they're safe, and they're reliable. And according to the auditors, building that trust starts way before anyone writes a single line of code. It begins with this really critical first step called problem framing. It's basically asking, what are we actually trying to solve with this AI? And does it align with our company's goals and our values? Because if you did this part wrong, even a perfectly built AI can lead to a total disaster. Now, check this out. This chart shows a metric that auditors live and breathe by: precision. A precision of 60% in, say, a fraud detection system might not sound too bad, but what it actually means is that for every 10 transactions it flags as fraud, 4 of them are totally legitimate. That's 4 angry customers whose payments just got wrongly declined. It's a huge reminder that accuracy isn't just about catching the bad guys, it's also about not punishing the good guys. So to keep track of all this, auditors use something called an AI model inventory. You can think of it like a master catalog for every single AI system running in a company. It spells out what each model does, why it even exists, and what business goal it's supposed to be achieving. This makes sure there are no rogue AIs running wild in the shadows, and that every single system is accountable. All right, so where does an audit actually begin? It starts with a concept that's as old as computers themselves, but it has never been more important: the quality of the data. Because with AI, it is literally garbage in, garbage out. The ISACA AI Audit Study Guide just nails this point. It says that the foundation of any high-performing and ethical AI is its data. You can have the most brilliant algorithm in the universe, but if you train it on biased, incomplete, or just flat-out wrong data, you're going to get a biased and wrong AI. It's that simple. Trustworthy AI has to be built on trustworthy data. So how do auditors make sure the data is actually trustworthy? Well, one of their key techniques is establishing what's called data lineage. This is basically being a detective for your data. It means you can trace every little piece of information right from its original source, follow it through every change it undergoes, all the way to how it's used in an AI model. That kind of transparency is what creates real accountability. And this is a perfect illustration of the difference between being risky and being responsible with data. On the risky side, using postal codes to help figure out credit scores. Now, why is that so bad? Because your postal code can easily be a substitute or proxy for things like race or income, and that leads straight to discrimination. The responsible approach? Things like periodic bias testing, where you're actively hunting for and correcting these kinds of unfair outcomes. And of course, data isn't something that just sits still. The world changes, right? Customer behavior shifts, the economy goes up and down, and this creates a huge problem that auditors call data drift. A model trained on, say, pre-pandemic shopping habits might be completely useless today.
As the real world drifts further and further away from the data the model was trained on, its accuracy just tanks and it starts making bad calls. That's why a set it and forget it mindset is so dangerous with AI. So even if you manage to get perfect data, which is a huge challenge in itself, that's really only half the battle. The next big hurdle is understanding what the AI is actually doing with that data. It's all about cracking open that infamous black box to see how it thinks. I mean, think about it. If an AI denies you a loan, you have a right to know why. And for any company to be responsible, it has to be able to explain the decisions its AI makes. Without that transparency, what auditors call explainability, there's no way to have real accountability. We just can't accept the computer said no as a final answer anymore. And auditors have a whole toolkit just for this. They'll dig into audit trails, which are kind of like a flight recorder for the AI, logging every single step in its process. They use these powerful explainability tools that can translate all the complex math into reasons a human can actually understand. And of course, they spend hours and hours reviewing the model's outputs, just looking for weird patterns or hidden biases. It's a full-on effort to make the invisible visible. But even with pristine data and a completely transparent system, there is one last absolutely crucial element. It's maybe the most important safeguard of all, making sure a human being is always in charge. The source material we've been looking at is so clear on this point. It says the single greatest risk is letting AI just operate completely on its own, making decisions and generating outcomes without any human review. That's where the really catastrophic errors can happen. It doesn't matter how smart the machine gets. Human judgment and oversight are completely non-negotiable. And this is what that human-in-the-loop system looks like in the real world. First, the AI does its thing. It analyzes the data and it makes a recommendation. It doesn't make the final decision. Then, a human expert comes in. They review what the AI suggested and its reasoning. And finally, that person makes the final, accountable call. You get the speed of the machine combined with the wisdom and the ethics of a person. So as we start to wrap this up, what is the path forward? Building trust in AI isn't about having some kind of blind faith. It's about building a rigorous, verifiable system of checks and balances. So let's just recap the big principles here. First, it all starts with framing the right problem. Second, you have to build everything on a foundation of high-quality, trustworthy data that's non-negotiable. Third, you have to demand transparency and make sure the system can actually explain itself. And finally, never, ever take the human out of the loop. They have to have the final say. And this leaves us with one final big thought to chew on. We know AI is a tool. It's built by people, and it's trained on data created by our society. But in this new world of complex algorithms and self-learning systems, figuring out who is truly accountable when things go wrong, well, that might be one of the biggest challenges we're going to face.